this is related to the lesson that we talked about on Tuesday. We're given the graph of our feasible solutions. So they did this part for us already. The region is shaded in. We want to find the maximum and minimum values of our objective function. And our objective function was that. And so the strategy is, well, there are infinitely many points in here. Do we want to do this infinitely many times, or do we want to focus on just certain numbers?
What was the question?
So we want to find the maximum and minimum values within this region for this function. How are we going to do that?
Plug in the corner points.
Plug in the,
into
so
that
that's
equation.
that's the catch we have to remember, and that may seem like a super easy thing, but that's something we need to remember. Our answers are going to be at one of the corners. There are only 4 corners in this thing. Those were so 4, 9, 7, 5, 8, 3. I don't know, do I have enough room? 2, 2. And so we're just going to plug in these numbers for x and y. So 4 times 5, 20, plus 18, oops, 38. $35 plus 10, 45. 40 plus 6, 46, and then 10 plus 4 is 14. The maximum value of the objective function, so looking at these numbers, the largest of them is 46, barely, but good enough. The maximum value it was located where? The point that gave us that was 8, 3. The minimum value of the objective function, the smallest number is 14. And that happened at 2. 2. Questions about that?
So the minimum is always going to be the lowest point on the graph, right? But the max will not always be.
I'd be reluctant to jump to any conclusions like that. I would just plug them in and see what you get. I think if these numbers are both positive, then it's likely that the minimum will be the one that's closest to 0, 0. But if one of these had been negative, that could have messed it up. So I would just work it out. What you get is what you get. Other questions? Old questions? Homework questions?
On the